Hi, this is Rakbadi, working as assistant professor in Government College of Engineering, Body Nakinor. So here, this video lecture is presenting non-destructive test of concrete element. So the contents are to be covered in this video lectures are introduction, brief of NDT test, rebound hammer test, UPB test, that is ultrasonic pulse velocity test, electromagnetic cover measurement, radiography, some latest technology in NDT, then pull-out test. So here some methodologies are followed in testing. The first one is non-destructive. So this non-destructive test is performing in which it does not destroy the test specimen. So whatever the concrete or any structures which is undergone for non-destructive test, so in that case that specimen does not destroy. So after testing, allow the part to be used for its intent purpose. Then in case of destructive test, we see that tests are carried out until the specimen's failure, whereas then it will render the part unusable for its intent purpose. So here in case of non-destructive test, the structures will not be disturbed in its function. Okay, so let us see those all things in detail in further slides. Why we need that NDT, that is non-destructive testing. So the assessment of existing structures in the absence of drawings, then quick assessment of the structure, quality control of construction in situ, then determining position of reinforcement, then location of cracks, joints, honeycombing. In some cases, it required to assess concrete damaged due to fire, then due to fire or any other natural calamity, do you judge the condition of structures. So suppose if we want to check the, or if we want to assess the some existing structure, so we go for NDT. So that is most suited thing, because without affecting the functionality of the structures, there are different tests can be carried out with the use of this NDT. So this is the major reason why do we use this NDT. Then what is the scope of this test? So it suggests the methodology to be followed and applicability of non-destructive testing. Then automatic interpretation of data from NDT with the goal of detecting flaws accurately and efficiently. The proposed retrofitting techniques for structures failing in this kind of testing. Then cost effectiveness. Destructive testing. Huge cost initially has to put in for taking samples and then to test it. So because we have to destruct, or we have to damage the structures, or we have to take some part of the structures as specimen, then it has to be tested and it has to be analyzed. In case of NDT, it is very easy and a simple process, and a many tests can be performed on concrete, less amount required for sampling of concrete. So then let us see some advantages in the NDT. So the access to hidden items, see-through walls, better investigation with NDT, rapid and on-site accumulation of data, generally less expensive than destructive testing. It gives result without structural damage. So these are all some of the major advantages. Then more than one test method may be required. So environmental conditions, so these are all some disadvantages in this NDT, because if we use single techniques in this NDT, so it is not reliable, it is not showing the reliable test. For that we should go for some other test. So environmental conditions may affect or distort result, so which invent some results, which give some intervention in the results, the environmental conditions. So because the results value may vary with the time or with the season. So then construction details and building components may affect results. Then some conditions cannot be determined with the reasonable degree of accuracy without a destructive testing. Yes, in some cases we should also, the test results are to be produced with the aid of the destructive testing results. Then let us see some the techniques, that is NDT, that we suggest for the different types of works. For example, in case of strength evaluation of concrete, we go for, suppose if we want to know the surface strength, so with the use of rebound number. So in this case, surface zone strength assessment, we can use the rebound hammer. Then homogeneity of concrete. Then in order to assess the quality of concrete inside of the concrete, so we can prefer the ultrasonic pulse velocity. Then combined ultrasonic and rebound hammer determination to determine the uniformity, homogeneity, location of internal defects, if there is any internal cracks formed or not. So then we go for both ultrasonic pulse velocity tester and rebound hammer. Then pull off strength. So this is the surface zone strength assessment. So here we use the pull off tester. Then pull out force surface, in order to find the surface zone strength assessment. So here pull out log test or construction stage, pull out capo test after construction. So here we are using these two stages of test. Then break off test at failure can be related to compressive flexural strength with the use of break off tester. So then penetration resistance surface zone strength assessment, here we use the Windsor probe. Then if we want to know the corrosion assessment, then location and die of the rebar and cover. So for that, suppose if we want to know the corrosion potential, that is offset status of corrosion activity, we can this thing can be determined with the use of off-cell potentiometer. Suppose we want to find the resistivity, then rate of probable corrosion, we can use the resistivity meter. Then to determine the carbonation depth, that is penetration of carbonation, so that we can find the corrosion risks and the causes. So that thing it can be find the carbonation test kit. Then chloride content, corrosion risk and cause, we can use the chloride field test system. So further, if we want to know the voids and corrosion, so then viewing interior part of concrete, so we just go for endoscopy. Then scanning of die of rebar and cover, it is used for locating rebars, diameter rebars and the concrete cover. So that thing can be done with the use of profometer, or we can use the rebar locator. Then cover and rebar measurement, corrosion risk and cause, so with the use of micro cover meter. Then if we want to find the crock measurement in building and structures, so we can use some other equipment, the NDT equipment. So length changes, strain measurement using digital strain gauges, radiography images, cracks, location of rebars, radiographic source and detector with the use of equipment, radiographic source and detector. Then acoustic emission technique, so that thing can be measured to measure the location and activity of cracks with the use of Spartan and Mistras system. Then infrared images, this is one kind of measurement. We can directly trace the infrared images, so that the cracks delamination, then this thing can be done infrared thermal imaging systems. So then let us see some NDT equipment. So with that equipment, how can we do this this kind of test, that is NDT, can be carried out. So first thing, rebound hammer test. So so here there is a figure which is given. So a man which is handling that rebound hammer, so in which what is he going to find. So with the use of this rebound hammer, we can find the compressive strength. At present, compressive strength of any specimen or any member as on. So this is the best method which can be done at this site. So this is in situ method. So to find the compressive strength of concrete with the help of suitable correlation between rebound index and compressive strength. So assessment the uniformity of concrete, assessing the uniformity concrete, we can also assessing the quality of concrete in relation to standard requirement. So how what is its principle behind this thing? It works on the principle that the rebound of an elastic mass depends on the hardness of surface against which the mass impinges. So this is the rebound hammer diagram. You see that here the spring system, a piston system is available. So when we push these things, what happened here? Tubular housing, spring is available, rider, scale, spring. So here we can directly, with the use of the scale, the reading is directly shown some value. Then that value is being related with the compressive strength of concrete. So we are getting directly the impact energy for different application. So for testing normal weight concrete, so impact energy is about 2.25 Newton meter. Then for lightweight concrete or small and impact sensitive parts of concrete, it's about 0.75 Newton meter. For testing mass concrete, for example in roads, airfields, pavements and hydraulic structure, it is showing about 30 Newton meter. So this is the methods that we are using this hammer. So procedure, this is the first, we just place over that sample or any member on the real structure, on-site structures. Then we just push the piston and it should be fully pushed. So after that it has to be released. So some of the points, that important points to be considered while doing this test. For testing smooth, clean and dry surfaces to be selected. So because the undulation should be avoided. Then rough surface resulting from incomplete compaction, loss of groove, spalled surface do not give reliable result and should be avoided. Then the point of impact should be at least 20 mm away from the any edge or shape discontinuity. For taking measurement, the rebound hammer should be held at right angles to the surface of concrete member. So it should always be positioned right angle to the surface. Then around each point of observation, 6 average of these readings of rebound indices are taken and average of these readings after detecting outliers becomes the rebound index for the point of observation. Yes. Then some factors which affects this result. So type of cement. Concrete made with high alumina cement can give strength 100% higher than with the OPC cement. Concrete made with super sulfate cement can give 50% lower strength. Yes. Then type of aggregate. Gravel and crushed rock aggregate gives similar correlation, but concrete made with lightwood aggregates requires special calibration. So some other surface moisture contents of concrete. Because a wet surface will give 20% lower strength in an equivalent dry concrete. Then age of concrete. Then carbonation of concrete surface. So these are also which influence the strength of concrete. So then interpretation of results. Suppose the average rebound number more than 40, so its quality is very good and hard layer. So if its value in between 30 to 40, then it can be designated as good layer. So then that value is 20 to 30, it is fair quality of concrete. If its value is less than 20, that concrete is said as poor concrete. So like that we can designate the concrete based on that rebound values. Yes. So the next test is ultrasonic pulse velocity test. So this is the another NDT equipment that normally used to determine the strength of concrete. So here the homogeneity of concrete. So here we can find the use of this in ultrasonic pulse velocity, how the concrete is homogeneously casted. Then the presence of cracks, voids and other imperfections. Then changes in the structures of the concrete which may occur with the time. The quality of the concrete in relation to standard requirements. The values of dynamic elastic modulus of the concrete. These all things can be carried out with the use of this ultrasonic. Then UPV test. So what is the principle behind? The method is based on the principle that the velocity of an ultrasonic pulse through any material depends upon the density modulus of velocity of material. So which means the ultrasonic waves are transmitted when it is transmitted into concrete. If it is very homogeneous and highly packed, which means there will not be, if there is any honeycombed, means that waves will be reflected and it will reach in another portions. It is taking some more time. So let us discuss the further slides. So this is the schematic view of the UPV equipment. It includes a transducer, a receiver, and an indicator for showing the time of travel from the transducer to the receiver. So here actually so you see that this is this is called as one transducer. This is another transducer, and one is being used as transducer and another one is being used as receiver. Okay, receiver, and this is the method that we can sorry, actually this is one is transducer, another one is being used as a receiver. Now the time is directly be calculated with the use of this digital meter. Okay, so how much time it will take to transmit this ultrasonic wave from one place to the another place. So this is transducer, another one is receiver, like that we are taking. The next slide. So how it works? Ultrasonic waves are very similar to light waves in that they can be reflected and refracted and focused. Reflection and refraction occurs when sound waves interact with the interfaces of differing acoustic properties. Ultrasonic reflection from the presence of discontinuous of geometric features enables reflection and location. So like that the waves are transmitted. And this is the formula to be find the ultrasonic pulse velocity in kilometer per second. So the formula is V is equal to L by T. We know the length of the specimen and what is the time taken. With the use of, we can find the ultrasonic pulse velocity, and then these values are being compared with this standard data up to 500. Then natural frequency of transducer that we are using 150 kHz, that transmitting of waves with the use of this frequency. Then minimum traverse dimension is 25 mm, then 500 to 70 mm. So like that we are taking the different frequencies and its range. Yes, now the results were interpreted with the use of this. If the pulse velocity is above 4.5 km per second, then it is excellent. Then velocity is 3.5 km per second to 4.5 km per second, it is good. 3 to 3.5 medium, and below 3 is doubtful, concrete quality. So then next one is the electromagnetic cover measurements, the another NDT. So it is the basic principle is that the presence of steel affects the field of an electromagnet. So here we can find with the use of this electromagnetic principle in which where the steel is being placed within the concrete, so that it's affecting that electromagnetic wave. So with that principle they are using. So here the quality control to ensure correct location and cover reinforcing parts after concrete placement. Then investigation of concrete members for which record are not available or need to be checked. The location of buried ferromagnetic objects other than reinforcement, example water pipes, steel joints, lighting, conduits. So this the that electromagnetic waves. So the next one is the half cell potential.